Hi guys, welcome back. This is part 2 of the how to move a humanoid model tutorial. In this tutorial, I'll be showing you how to move a humanoid model within an area with this unique shape. This is a box shape, but it's missing a corner. From the last tutorial, we've created a cube as our humanoid model. Then, we wrote the script to make it so that the cube will spawn inside of this area and it can only move within this area. Now, I will copy this area a few more times. And then I will shape it so that it will become the shape that I've shown you. So this is the shape that we'll be working with. As you can see, I just copied the first area multiple times and combined them to one larger area. To make your life easier, I will recommend you to do the same. Now, from any of the folder, aside from the original one, rename it to whatever you want. I'll be calling it area 2. And from the other folder, you can select on ground and the moving points and transfer it to the area 2 folder. Now you can delete both of this folder. Now you can select on all of the moving points folder and group them as folder. And because we just copy the first area, you can see that for every area there will be 2 parts in each corner. So we can separate them by name. I will just call it area 1, 2 and 3. You can name it whatever you want. I'll put back the line so that we can distinguish each area. Now that we have the area, you can write the script to make the cube move inside of this area. So from our previous tutorial, we already created the script to move the cube inside of this area. You can copy the script. So I will rename this to area 1 because this script belongs to area 1. So this will be area 2. Now inside the cube module script, instead of area 1, we can change it to area 2. And instead of the moving points folder, if you look at the area 2 folder, it contains section for the area. So in this area there is 3 sections, so I will call it sections. And I will rename this folder to sections. Now, from the last tutorial, we have created this for loop to get the position of the parts inside of this moving points folder, and then we store it inside of this points table. But now, instead of only one folder, we have 3 folders, and they also had a parent folder. So to fix this, what we can do is to first create an empty table. I will call this table section. Now, to access each folder inside of this sections folder, we can do a for loop. Then to get the position of the parts, we can just copy this for loop. Pass the folder inside of this. And then inside of this section table, we can store the folder name as key. And the value will be the points table. Now, to see the value inside of this section table, we can print the table. So create a function called cube.test and print the section table. And inside the main script, we can call the test function. Now you can run the game. And under script, click on output. And you can see the structure of the section table. So it has the folder name and the position of the parts. Now, when we go back to the cube module script, we can see that the get random position function is no longer working. This is because we don't have the points table anymore. To get the points table, we need to access the section table first, and then we need to decide which of the section that we want, and then we can get the points value. So what we can do is to create another function, which will be cube dot get random section. Then we will need to create a table to get the name of the folder first, so that we can randomize it. So local possible section for key in section, we will insert into possible section the value of key. Now when we have the table, we can randomize it, so it will choose between 1, 2 or 3. So we can do local select section is equals to possible section and method random the length of possible section. This will choose between 1, 2 or 3, and then we can get the points section of the selected section, and we can return the points. Now we no longer need the parameter. Instead, we can call the getRandomSection function. Now go to the main script and change this to cube.main. And if I run the game, we can see that the cube is spawning and moving inside of this area. If I let the cube move long enough, we can sometimes see that the cube will move outside of this area. This is because the humanoid move to function calculates the shortest path from the cube current position to its destination. In this case, the cube is trying to move from this section to this section. The same is true if I have another section right here, and the cube is trying to move from this section to this section. The shortest path will require the cube to move outside of this assigned area. While we can use the pathfinding service to solve this issue, it can consume lots of resources. This is because the pathfinding service will create many waypoints to get an object to move from point A to point B, while the move to function just create a single waypoint. If you have many objects, for example, if I were to spawn the cube 10 times, if I have this 10 cube and all of them using the pathfinding service, it will cause performance issues. So to save some resources and to get the cube only to move within this area, we can give the cube a mind to think. For example, if this is section 1, this is section 2, and this is section 3, if the cube is in section 1, it can only move within section 1, or it can move to section 2. If the cube is in section 2, it can move only within section 2, or it can move to section 1 or section 3. And lastly, if the cube is in section 3, it can only move within the section 3, or it can move to section 2. So by this logic, the cube will never get the chance to move outside of this area. With that in mind, under the cube model script, insert another module script, and I will call this brain, because this will help the cube to think where to go. And I will return the logic that I've shown you. So if the cube is in section 1, it can only go to section 1 or 2, and so on. So inside your cube model script, you can require the brain, and we will need to remember the current position to plan for the next position. So to get the current position of the cube, firstly go to the main function and introduce a new variable, which should be the current section, and pass this value to the getRandomPosition function. So this function will require current section as the parameter, and pass this value to the getRandomSection function, and this function will also require the current section as parameter. Now to recycle the section, we can return the selected section. So this will give two value, which should be local points and selected section, and we also need to return the selected section right here. So inside the cube.spawn, we will need to get the two value, which will be the selected C frame and selected section is equals to cube.getRandomPosition. Now we can pass the selected C frame instead of the pivot to function and return the selected section. So this will return cube and selected section, and we can update the selected section every time we call the getRandomPosition function. And the current section will also be equals to the selected section. Now that we have the current position of the cube, the next thing that we need to do is to tell the cube where it can move to. So under the getRandomSection function, change the table name to possible next section. And if current section, then we tell the cube where it can go to based on the current position. Otherwise, we call this for loop. So if the cube has no current position, meaning that the cube still not spawned yet, then it can choose where to spawn between the section 1, 2 or 3. Now, if I click run, we can see that these 10 cubes will never move outside of this area. If you want your humanoid model to look a lot more natural when moving, you can change the configuration instead of the main function. For example, you can change the speed to 24, which will be the default movement speed, and you can wait 3 to 5 seconds between each move. So test the wait. Let's do random 3 to 5. Now the cube will look a lot more natural when moving. But for tutorial purposes, I will keep my movement speed to 5 times. That's all for the part 2 of this tutorial. In the next part, I will show you how you can implement the pathfinding service instead of the script. While using the pathfinding service can be really resourceful, there are times when using it is necessary. Thank you for watching.